pass on this to my colleagues joining us. So thanks for joining us today for this preferred structural design software in Africa, a presentation of ProtaStructure Suite. Okay. Joining me today, I have two very interesting people with us, part of Prota for many years. One is engineer Idu Ofinku, which is the managing director for Trackforth Engineering Limited and a Prota reseller for Nigeria. Also presenting today is going to be engineer Mustafa Tumertan, which is the founder of Tan Software Engineering and partner at Prota Software. He's a senior software architect and structural engineer, okay? And myself, a regional channel manager at Prota Software, okay? So today we're going to be reviewing a couple of things. Engineer Idu is going to give us his view of what's happening currently in this market, in African market, okay? And then Engineer Mustafa is going to take us through certain solutions that we know that we can offer, we as in Prota Software, to improve people's ability to work in these markets, okay? So the great thing is that we're not just showing a little fantasy presentation. This is the real thing. You know, you need drawings, you need to have the knowledge of what you need there, the type of reports, and a Prota Software is getting you all this, okay? I'm just going to do a short presentation of what we are about, okay? And it's going to be just a little overview of the software and the products. What do we offer? The core advantages, okay? A few project references, and then we'll just hand it over to the presentation, all right? So, ProtaStructure's a suite. ProtaStructure is a unique platform, okay, building on design and the sole offering that we provide customers worldwide an entire solution, okay? Why do we consider ourselves different? Well, we feel that by integrating modeling, analysis, design, detailing, fabrication, BIM process seamlessly, it allows you to integrate the whole process in one delivery, in one solution. And this way, it allows the users to rapidly deliver a project, which is what we need to do at the end of the day. All right. Now, ProtaStructure Suite, it consists of 4 modules. They're all within ProtaStructure Suite. So you're just installing one package, okay, and it's all in there. And we have ProtaStructure, which is the core system for modeling, analysis, design systems for your structure. Then it's complemented with other tools like ProtaDetails. It's a complete CAD system, automated detailing drawings, and it's focused on concrete detailing, including a library of unique designs, so forth. Then we have ProtaSteel, which is it complements the steel design by automating all the steelwork connections design and providing comprehensive steel detailing, automated connections, and tons of things. And then we have ProtaBIM, which allows you to connect into other tools, allowing you to collaborate better with team members. And it allows you to go into other BIM platforms of software, such as Allplan through IFCs or Arcadia through SAF, or into even share analytical data with SAP and ETABS, okay? For more than 40 years, we've been growing, and so far we're already in over 10 languages. In Africa, you have obviously English, but also French speakers and some Portuguese, and we have the solutions for you guys as well. We have many design codes, including the most used and sought after in this market, and we've expanded with certain partners or global offices. The red dots show the partners. And there you see Nigeria. That's where Trackforth Engineering engineer Idu comes in with us. Okay, just a quick, brief through the summary of some of the milestones of Prota Software's journey throughout the years. Obviously, there's more, but these are just some of the main ones. And you might actually remember us originally as Prota launched Probina Orion, which was the world's first concrete building design system, in actually 1992. I was a teenager back then. Back in 2005, Probina Orion also provided the first ever retrofit solution and rehabilitation. So we're also doing retrofit and rehabilitation. Then in 2007, Prota invested in BIM technology and launched ProtaBIM, which As mentioned before, it provides, among other things, a bidirectional physical model integration. Okay. Now, ProtaStructure was introduced in 2014, which is this program that is so sought after in the African market. In 2018, we actually delivered the world's largest passenger terminal building. The structural design of this project was delivered with ProtaStructure Suite. If you would like to know more information, we'll see that a little bit farther along. And in 2026, we currently stand with software being used in up to 95 countries. All right, so what I mentioned that differentiates us, you're normally, most people here, most engineers were likely using one tool for modeling and analysis, like the ones showing here, ETAP, ZAB, so forth. Some of these tools might be able to design, but if not, maybe you might need a design element tool such as SAFE and things along these lines. Then for component design, you're also likely going to need an additional tool when it comes to maybe CAD scale, Procon, so forth. If you want to do detailing and drafting, you'll have to go into a CAD software, either AutoCAD, BriskCAD, G-StarCAD, but some sort of detailing drafting. And lastly, if you want, well, not lastly, if you want to fabricate this product that you've designed in steel, you're going to have to go into another solution like the ones here. And lastly, if you want to share with other collaborators in a BIM environment, that will be needed to be done likely in another software. That's why we have mentioned that we pride ourselves in creating a program that has been able to cover all of the different parameters from modeling, analysis, and design with ProtaStructure, detailing, drafting, component design with ProtaDetails, fabrication of steel features with ProtaSteel, and the sharing of data with ProtaBIM. And as I said, everything is under one software, one umbrella. You're not going from one software to another. Okay. ProtaStructure Suite has developed always with BIM in mind. And here on the slide, you can see the entire BIM workflow that our software solution provides. Okay. And remember, all these are offered in a single economical suite called ProtaStructure Enterprise. Okay. Now, product excellence is a necessity in our sector, and it's also key to our success. ProtaStructure is being used by thousands of large enterprises all around the world, also small to medium enterprises. Everybody really can use this software, but these are some of the large ones that maybe you might recognize. In addition, as I mentioned earlier, ProtaStructure was used in modeling, designing of the biggest passenger terminal airport building located in Istanbul. Many of you probably traveled through here, covering over 1.5 million square meters. And General Manager Mr. Imut has made a statement from Prota Engineering that attributing the added success of ProtaStructure's ability to perform project variations quickly, economically, and accurately. Okay. As you can see here, we can also do projects like the largest university campus in Istanbul. This was also delivered with ProtaStructure. This is 50 buildings with a campus project covering over 1 million square feet. Also, projects like the King's Palace situated in Kuala Lumpur. It stands as the government's most significant project. Okay. And this was actually delivered by another one of our users, Kema Paket in Malaysia. And it was a product that was also able to design this type of structures. And also, you will see many high risers around the world from companies like TWT Design Consultants that delivered these products, or also projects from other parts of the world, such as Camel Street London or Stage London, and other important buildings around the world. These in particular that delivered by Maverick Consulting Engineers. Also, as I mentioned, several hospitals were also designed with ProtaStructure Suite, but this is one worthy note that these hospitals were actually seismically retrofitted buildings. So with ProtaStructure Suite unique capabilities, you can insert seismic isolators into your buildings too. You can also see important international airports delivered throughout parts of the world, and just our where our customers each time are becoming more and more creative with the software's flexibility. So you see that there's really no limit to the type of structures that people are starting to bring out nowadays. Okay. We have what we offer to clients that become customers. Our licensed customers have access to our help center platform for one entire year for you to assist you in onboarding and all assistance that you need when you start with a new software. In addition to a white paper and blogs that we offer for additional technical support that people might need in certain parts of the project, and of course, great platform for you to view videos, even entire training data on our software. Okay, and mostly some of you might want to try the software in the next day or two, or after you see this presentation. You're welcome to do so here. If you do download the QR, just remember that for you to download the trial, it's important that you will be on a computer, on a PC, or on a laptop. You can download the trial into your phone, for example. Okay, with that being said, I will continue on, but right now I'm going to turn it over to Engineer Edu. Okay, and I'll go ahead and I'll stop sharing my screen. And if you could kindly try to share your screen now, please. Hello?
Yes, you have to
I
enable me.
stopped sharing already. I stopped sharing.
Okay. You have to enable me. Okay.
They're gonna enable you in a second. Hello, can you share the license the can you share now your screen or no?
No, it's still deactivated.
Can I have somebody from the Prota team that's connected? I think Doga's here. If she can give him access. All right. Well, what we can do, we can start a second with, if not, we can start with Engineer Mustafa, and then we can turn it over to you at the end. What do you think?
That's very okay.
Engineer Mustafa, are you able to share your screen?
Second, please.
Sure.
I hope you can see the screen.
Yes, yes, we can.
Okay, great. So, hello everyone. It's a pleasure for me to be presenting to you today. Uh, you know me already. I am Mustafa Tan, and I have been a partner at Prota Software for over 20 years now, and I'm now conducting my own venture, uh, Tan Software and Engineering. I'm still with Prota team. I'm supporting them by development and presentations So without further ado, let's start with the key features, key capabilities of ProtaStructure. So today I will not be conducting a demonstration of the software by entering axis columns, by doing the modeling. I think we have already passed that. You know how to create a model. It's very easy in ProtaStructure. Uh, um, it will take you like 15 minutes to create complicated structures from ground up. So it's not a big deal. So what I want to deal today is the logic behind ProtaStructure. What's the workflow? How we approach it. So the ProtaStructure is a template-based software. So when you start a project, you will see the different settings, different templates that we customized for each country. So when you start a project, you will not be starting from scratch. All the best practices, all the best settings, favorite settings will be automatically brought to you with the country. So we have several countries, including African countries as well. These are not only the settings, but also the design settings, detailing settings, etc. So materials, codes. So when we check the codes, you will see that we have several design codes, including Euro codes, American codes, uh, Brazilian, South American codes, Far East codes, and Turkish codes as well. So we support mostly use the design and international codes in the software. So in this project, we have Eurocode 2. So you have to select concrete and design codes separately in the software. So you can actually mix and match the codes. You can select Eurocode, for example, for the concrete code, but you can use AISC, American code, for the steel design. However, composite and steel design are coupled. You cannot select composite design code separately from the steel design code. They have to be coupled together. And also regarding the loading codes, we have, again, Euro codes and American codes. By loading code, I mean the distributed load values, uh, the wind loading values. These are all defined in the loading code. However, you can also set the wind loads separately from these again, because wind codes require us a lot of different complexities, including the load cases and the wind load angles. Especially for some of the codes, we have vortex effects, gust effects, so we have to include them very carefully. And lastly, we have the earthquake codes. Excuse me. Again, we support international earthquake codes. So the mostly known are the Eurocode 8s and the American codes. Of course, we have the South American codes as well. So what I mean by these settings, so uh, when you go to loading before setting up the model, maybe you have to set the load cases and combinations here. And the powerful feature of ProtaStructure is that depending on the selection of the code, design code, we have vertical loads and horizontal load combinations automatically prepared for you. All you have to do is select whether you want equivalent static or model response spectrum here. And also in the seismic codes, we have different requirements, like if you have a non-parallel system that is not in parallel with the earthquake direction, you can apply 30% of the other direction. Or if you have in your structure vertical earthquake effects are prominent, you can select the vertical seismic case and you can apply model or static earthquake cases. So, and also if you have imperfections in the system, or if the country that you operate is not a seismic country, but still you have to apply some notional minimum loads on the story level. So even when you have earthquake, you still have to apply a notional load because of the imperfections. So these notional load cases are also automatically generated, these are usually applied at a percentage of the story weight. And of course, the wind loading, you have to select here the loading to create the wind load cases here, and also the soil pressure. If you have basement walls or the members that will support the soil thrust, you have to select the soil pressure here. So, but you have to apply the soil pressure yourself on the structure. Anyway, as you see, all the combinations are automatically generated with the correct combination factors. You can also add new combinations. If you are not happy with the automatically created combinations, you can always add new combinations and you can edit the existing combinations as well. But one powerful feature in ProtaStructure is the ultimate limit state combinations for concrete and ultimate limit state combinations for steel. They are separate in the system. And also you can define the serviceability limit states combinations for RC and steel separately. These combinations will be used in the deflection checks. Anyway, so far so good. These are the combinations. But of course, in the building setup, you have materials. All the materials here are brought by the templates, and they are specific to the code that you have selected. And also for Eurocodes, you can specify the time-dependent properties of the material. We will use this in the long-term deflection check according to Eurocodes. So you define the creep and shrinkage strain diagrams here. In fact, they are automatically calculated using the time model of 90 or Eurocode again. And of course, we have a huge list of settings. We have collected the settings in a central user interface. So you can search, for example, rebar, and you can get all the settings, rebar-related settings here. Or you can type in column, you get all the column-related settings. But mostly you will spend time is the design settings, steel settings, or column settings, column shear wall and beam settings here. All the design settings, all the detailing settings are residing here. In fact, one important setting here is the units. These units are set by the template, but you can change it if you like. So you can change the reporting and the UI units separately. So this is not something you play with very much, but you have the flexibility to use Imperial, SI, or MKS units in the software. Anyway, so this is the settings. Maybe we can continue with the modeling here. So let me open up project for you that we have concrete and steel models together, members together. So as we say, ProtaStructure is a multi-material software. That means you can model steel and concrete members together. So beams and columns here, as you see, are modeled, and together with them, you have the steel members. All you have to do is select the appropriate member from here and model in the structure. But one thing important in steel structures is that we have to be careful about the production during modeling. Since concrete is a monolithic construction, so we don't have to be that careful. Of course, architectural eccentricities are important because when we do the detailing in concrete, of course, the eccentricities should be accurate so that we have all the appropriate bar bendings, all the dimensions accurate. So that's also important. But in steel, we have to be more careful because eccentricities should be compatible with the construction and constructability. For example, here in the girts, when you define insert the girts, they are automatically inserted at the column faces. Or when you insert the braces, you will be able to, for example, offset them by some amount from the column, but they will be still connected to the joints. And in steel modeling, we always separate analysis model from physical model. Because in engineering, we want simplicity in analytical modeling, and we want some flexibility in the physical model. Because while we insert the steel connections, we always want to shift the members by 10 or 20 centimeters, and we don't want the analytical model necessarily affected from it. So we can define all sorts of eccentricities here. Also, we have a purlin, that's again a macro member. All you have to do is select the trusses, and you will have the purlins inserted. And together with the purlins, we have the seg rods. These seg rods are not only for the visual, but they affect the design of the purlin as well, because they act as they restrain the purlin against the lateral torsional buckling, and they also are included in the analysis. You can, of course, exclude them from the model and from the analysis as well. And for the trusses, again, trusses are parametric in ProtaStructure. We have a library that you can use. Of course, what we do, we always try to match the centroidal lines of the truss members in order to make the connection perfect during the production. And of course, we have a concept called user-defined truss. You can, if you have a custom truss that is beyond the templates, or if you have the custom truss from your DXF file, you can import that into ProtaStructure, and you can use your own truss. Of course, these trusses are fully flexible. You can select the top chord and bottom chord sections, all the diagonal sections. They are more controllable. You can customize it the way you like. So this is for the steel modeling. Actually, it's a very flexible way of doing the model in ProtaStructure. So you can mix and match the structural members together. And the recent addition to ProtaStructure was, in fact, the pedestals and the sub-basement walls. Maybe I will explain it more specifically. In the steel structures, let's see the concrete. Okay, for the concrete, we can bury the concrete column within the foundation depth, because we can do so. But for the steel structure, for the steel column, we cannot bury the steel column within the foundation because soil will deteriorate the steel column, and it will affect it negatively. So all we have to do is to insert a pedestal under the steel column so that the pedestal itself is in the foundation and steel column is sitting on top of it. So this is what we brought. And sub-basement walls are also a part of foundation. In the previous versions, we had to model them with ordinary shear walls, and sometimes we had to create a separate story for the sub-basement walls. But now they are directly modeled in the foundation level. So this is the foundation level from the plan view, and we have a dedicated sub-basement wall member. And you can use this member to model the sub-basement walls. And they are included in the analysis, if you like. And you can apply loads on sub-basement walls. They can support other members. They can support lateral load. They can support the infield walls on top of them. Let's see if you have an infield wall. For example, you can go to the foundation level, edit loads, and you can insert a wall load on top of the sub-basement walls. So these are very handy members that close the gap at the transition from foundation to superstructure. We have introduced these members. Anyway, so far so good. Let's continue with another interesting project because let's see, it's called PL. Yes. And this is a very interesting structure. In fact, as you see, this is not a building. This is an overhang structure. It looks ugly, but our users are able to design structures like this. You can use ProtaStructure as a general purpose analysis package. There's nothing stopping you because you don't have to have any columns or shear walls or beams in the system. Well, you can design a structure like this using the frame members. Okay, let's see, for example, this member here is we have supports. You can assign supports to any members in ProtaStructure. So by assigning supports to these members, now our user modeled and designed an overhang steel construction structure like this. So, and using of course, the loading editor, you can load the structure any way you like. Or you can select a single member and edit load. You can assign loads on the member. It can be a trapezoidal load, it can be a partial load or point load. It's very flexible. So now with the additions that we did with the program, in fact, maybe it's correct to say the sky is the limit in the software because, as you see, this is one of the structures that our users model. And our users model pedestrian bridges, all sort of playgrounds, steel structures that are really having parametric shapes. So this is the way we are going at the moment. We are going beyond the conventional structures as well. Another structure can be, again, somewhat conventional, but this is, again, an interesting structure because it's a sports complex. So this is a sports complex. As you see, we have a large sport area here, arena here, and this is covered with the space truss. So again, with the addition of space truss, you can now model this kind of structure, design these kind of structures here. So this is again a very good example of a composite concrete plus steel together. So and you open the properties, you will see that this is parametric. You can control the parameters and you can control the space truss cells, and etc., the sections and the loading on top of it. Let's see. I'll show you another building, which is a pretty much a standard steel building, but this is again from one of our users. This is a storage building made with steel members. So we have trusses with pipe sections here, purlins and claddings. And as you see, we have the brace members. So there's brace members are also parametric. You can define it with a brace macro here. Let's see. Yeah. Okay. Another maybe interesting thing that this thing is for demonstration purposes. I had modeled this building to show the castellated beam features. So now in ProtaStructure, we have the castellated beams. So all you have to do is go to the properties, And the castellated beam property, you can select hexagonal openings, you can select circular, and it will be a cellular beam, etc. You can control the parameters here. And the design of the castellated beam is also using the proper checks. Let's see, we have the analysis here. Let's go to the design of this steel member design. Okay, let's check the design and detailed reports. The castellated beams are different than the ordinary beams because you have to do a post bending, web post bending, because in between the two openings you have a small portion that's susceptible to bending and buckling. So you have to check those web post buckling and web post bending, and also that small portion between the openings is susceptible to shear. So you have to check the horizontal shear as well. So in addition to the standard checks, you have the additional checks here. Anyway, okay, let's close this one. Let me show you another. This is again from one of our users. It's a steel building, but it's a larger one, a larger complex than the ones I showed you. So what is different here is, let's, for example, change the view to rendered. Okay, so this is again steel columns, steel rafters, and trusses as well. So we have here the brace members with the brace macros. But here, as you see, in between these two columns, we have two braces defined as a brace group. So when you have to model multiple braces here, you can do it with the brace group functionality. And this is, again, in between these two braces, our user modeled a vertical brace with the frame member. So you can mix and match the macro members and normal frame members in the model. So this is a normal frame member, and it is type, the frame type is vertical brace. So you can do this very easily. It's fun to do it in ProtaStructure, in fact, but this is here one interesting modeling approach. Now, this is also a horizontal brace, but here you see we have a dashed line representation of the analysis model. The physical model is slightly above the analytical model. That means this frame, let's open the view, linear view. This frame is in fact connecting to the purlin, connecting to the beam and the column here at the analytical model level. But when you switch to the rendered view, you will see that in fact the physical number is slightly above the analysis model. That's because we have to coincide the physical numbers to do a proper connection. And we don't want the analysis model to be a dirty model full of rigid links, full of small eccentricities, etc. Of course, in the analysis models, eccentricities are necessary when they are significant and when they affect the design. But for these kind of cases, eccentricities are usually within the limits, and you can just simplify the analysis model. Okay, and let's check the properties of this frame, for example. And when you go to the 3D, you will see that I have an in-plane offset of 10.5 centimeters. In plane, it has a 10.5 centimeter offset. Okay. And yes, let's go to the other model. And we have a very recent addition in ProtaStructure 2026, which is the stairs. In fact, we had the stairs before. In the previous versions, we had the stair design functionality, in ProtaDetails, we were able to design the stairs, but with the new ProtaStructure, you are able to model them inside the building. So let's check the 3D view. As you see, first of all, in the foundation, we have the sub-basement walls, sub-basement slabs. Of course, the sub-basement walls uh, are supporting the infill around the. They are not like basement walls. They are different than the basement walls. In the structure, we don't have basement. If you have basements, you don't need the sub-basement walls. Um, Sub-basement walls are usually for structures that don't have the basement walls, really, because some structures are already 1 or 2 story below the ground, so you don't need a sub-basement member to do the transition. If your structure doesn't have 1 or 2 story basement, if it sits directly on the ground, of course, you have to bury this foundation by some amount, like 1 meter or 1.5 meter, and you have to you have to do the transition with the sub basement wall. That 1.5 meter infill will be supported by the sub basement walls, and also, and let's hide this, hide selected. Also, inside this one, you will have the infill as well. Sorry, yes, it's soil fill as well. And on top of that soil fill, you will just lay some fabric mesh reinforcement, and that's all. And then you will have the sub-basement, sorry, show all sub-basement slab. So this sandwich here, this is here is a part of the foundation. Okay, let's see what we have here. We have the staircase. All you have to do is just show the region. I will not do the demonstration. It's very easy. So all you have to do is just select the staircase, insert using 2 diagonals. You select 2 diagonals here. You show the place that you want to insert the stair, and we have a dedicated stair editor here. So you select the type. It can be a straight. It can be straight with a single landing, an L shape, or U shape, or U shape with 2 landings. We will increase the types here. Of course, we are currently working on spiral reinforcement or helical staircase. But this is parametric. You can select the landing width. You can specify the landing width or the flight width. Here, number of threads, all customizable, and you can even see the rebars in 3D here. And all the detailed drawings are created using this rebar. The best part is, okay, when you do it, it will be, of course, generated to all the similar stories. And let's check one of the stairs here. So all the self weights and the other loads are automatically applied. But if you want to apply additional loads here, you can apply additional loads to the staircase. This is like any other regular member. So this is very easy. And let me directly jump to the analysis model. The best part here is you can model the stairs with the building. Okay, this is the magic here, because first of all, you have to mesh the slab with the staircase. Otherwise, it will not be a nice model. We recommend you to mesh the slab with the staircase. But I must admit that modeling of staircases with the building is a controversial topic. So engineers are discussing whether we should include the stairs in the model or not. In fact, the stairs are the members that will maybe be damaged first in the earthquake. So by modeling them modeling them with the building, what we do, we introduce a stiffness between these 2 stories. Let's close the displacements. As you see here, these staircases will act as a brace member between two stories. They will just, in your model, they will try to limit the uh, relative drift or lateral drift of the structure. Maybe it is best to exclude them from the building and see how the drift changes, or you can do another model and you can include the stairs. So modeling stairs together with the building model may do more harm than the good. Uh, so you must be careful to do that. Uh, Everything integrated is not always a good thing. But this was our user request. The best part here is you can design the staircase with the finite element. So here you see we have, uh, let's see the mode diagrams. Okay. Okay. So we have the slab strips, and we collect the moment values along the slab strips. And when we go to design, let's go to the staircase design. You will see the staircases in the model. Oops, I recently changed the model. I think I made a mistake here. Okay, let's start over again. Sorry for this one. Okay. And we are not done yet because in addition to the stair functionality and steel and concrete functionality, we also have a very strong functionality we call the composite slabs. In ProtaStructure, you can model and design the composite slabs as well. By composite slabs, I mean composite beams. So here in ProtaStructure, we have a frame type called secondary composite beam, primary composite beam. It's also here. So in frame, primary composite, secondary composite, and also you can insert a composite slab on top of these members. And of course, the composite slab has a deck direction. So you have to insert the deck. The deck direction must be perpendicular to the secondary member. So what we have here, let's see the properties. We have the deck, and all the effective widths between the decks will be calculated automatically because the composite uh, design is all about effective widths, and it's all about the composite degree action. So what I mean here is if you go to the setting and the composite member setting, what we usually start with an analysis, composite degree, and composite degree tolerance, because you have to assume that your members will behave at some composite degree. You cannot assume full composite action because there will always be some shear slips. There will always be some imperfections. So the interaction between the steel and the concrete will not be perfect. So there will be always a partial composite behavior. So we assume that at the beginning, the default value for the composite degree is the 50%. But of course, by changing that, you can, of course, change it. When you do the analysis, we assume we calculate this. Let's again, for example, a different one. We calculate this effective width using a composite degree, assumed composite degree at the beginning. So, and at the end of the analysis, what we do when you hit the analysis, let's see the analysis model first. And also maybe another model for the floor models. So analysis of the composite building is not straightforward because in the composite structures, we have the stage construction. This is not a stage construction like the high rises. This is different because when you do during the construction, you install the deck, but you don't pour the concrete first. That's one case. And the other case is you have the concrete, but it is not set out yet. It's a wet concrete, and it is nothing but a load to the system. And also, during the construction, you have a live load, but it's a construction live load. Let's see. Let's go to the story one and go to the properties. Properties. That's what we are asking live load during the construction. So it's the live loads caused by the workers, etc. So you enter that value, and while ProtaStructure does the analysis, it will do a floor by floor analysis. So for floor one, we do a construction stage analysis. But what we do before the concrete sets out, all the decks, all the secondary members are hinged. They are hinge connected. Okay, let's do the second story, and the loads on the members are the live loads from the construction. And after the concrete sets out, after the construction finishes, we now have the concrete, solid concrete, and now we don't have hinge connections anymore, and we have the final loads on the member. We have the final results for the structure. So we combine these results and we get the design values. And finally, you go to the design and the composite beams menu. For example, you have all the composites members here. Double click one of them. You will see that shear stats are calculated. So the design is also done according to the 50% composite action. But sometimes you will have difficulty in design because it's not straightforward. Okay, you can change the stud spacing, or you can change the composite degree. Okay, if you increase the composite degree, okay, you will say that it will be a 60% composite, then you will have to increase the number of studs, because in order to satisfy a more composite behavior, you will have to increase the studs. You can decrease the composite action. You can make it 40%. That means you don't trust the composite action. You can, you say that I will live my life with a less composite action, then you can decrease the composite action here. But if there's a tolerance of 10% between analysis and design composite action, you have to be careful about this. This is a bit detailed, but anyway, let's do the detailed report. At the end of the design, you will have a detailed report about all the details of the design step by step with formulas. Anyway, so this is very briefly what composite design is all about. Okay, let's go to the analysis part. Let's see what we have here, seismic parameters. Yeah. If you are doing a seismic design, of course, you have to set the seismic parameters. In ProtaStructure, we have a dedicated interface, a detailed interface for defining the design and elastic and design spectrum. And you can set the design spectrum in three different directions. So in X, Y, and Z directions, it's possible. All you have to do is you will select a structural system, and ProtaStructure will propose you a behavior factor that is automatically fetched from the code. But of course, you can always change the behavior factor with your hand here. It's manually editable. You can select a different behavior factor here. But be careful, you cannot select a ductile structural system in one direction and non-ductile in another direction. The ductility must match. And in vertical direction, we have a totally different spectrum than the lateral spectra. This is again calculated according to Eurocode, but all the parameters here are customizable. You can specify the vertical acceleration ratio or the vertical behavior factor. These are customizable, and if you are going to do a vertical earthquake analysis, you can use it. Okay, another important thing maybe worth mentioning here is the site-specific spectrum. So all you have to do, if you have a very weak soil that needs a site-specific study, of course you will get contract with an academician or seismologist or geotechnical engineer, and they will study your site and they will give you a site-specific spectrum. Then you will import from file. Maybe if you have spectrum from in a notepad or Excel, you can import that spectrum here, and you can use the site-specific spectrum in X and Y direction, and also in Z direction. Okay. Let's see. Maybe before vertical earthquake, I can mention it is a model from a user. This has a basement story, and it has a podium-like structure in the basement, and it is a 7-story building, and we have an equipment story here as well. So when you go to the edit story, you can of course set the parameters here, like one story is a sub-basement story, it's a basement story, or you can select the imposed load reduction here, because if you have a high rise, you will want to apply the imposed load reduction. And also for the earthquake, you can set the simultaneous presence for the imposed loads. Anyway, so when we do the analysis here, of course, I mentioned about the seismic parameters, but we have other things like model options. You can use the crack section properties this is again required by the most of the codes. You are not most of the time you are not allowed to use the gross section properties. You have to use certain crack section properties, and you can control these crack section properties here for the members like shell shear walls, mid pier shear walls, basement walls, slabs, columns, beams. Depending on the member type, you can set different effective section modifiers for different um, degrees of freedom for bending or axial or shear, etc. Anyway, so we have some options to review here. You can use a finite element shell model or mid-pier model. Finite element shell model is in the industry standards, but if you have a lot of shear walls that are very close to the column size, so if they are walls that have aspect ratio greater than 2, you can maybe use the mid-pier models for fast analysis. For the slab model, we have different diaphragm options. Of course, for most of the time, for the regular structures, slabs will be a rigid diaphragm. If there's no slab or diaphragm discontinuity or irregularity, for the first option, ProtaStructure will automatically decide whether your slabs will create a diaphragm or not. If your slabs are not touching each other, or if you have a stepping slabs or openings in the slabs, ProtaStructure will automatically assign multiple diaphragms or free nodes. Um, you can force the system, no matter what. You can say that, okay, solve the system with rigid diaphragms, no matter what. Or you can say, I don't want any rigid diaphragms at all. But in that case, if you want a flexible diaphragm behavior, you have to mesh the stories. Okay. Uh, if you don't want to see any flexible diaphragm, you can just use the conventional diaphragm approach. You can use the quad elements in floor mesh. You can include or exclude the slabs from the building, and you can control the shell element size here. Anyway, let's see the analysis model maybe. As you see here, the user wanted, let's switch to perspective view. A user wanted flexible diaphragm here, so they meshed the story. Let's close the results for a brief moment. As you see, we are using quad mesh in the slabs. This is also new in ProtaStructure 2026. Before that, we were only using the triangles, but now you are able to use the quad mesh as well. And we are doing a compatible mesh. So where are my notes here? Okay, so these are all compatible with the walls and the foundation as well. So let's check the results. Displacements here. So what we have here is the earthquake loads. We have EX load case. So you can check the displacement of the structure in each earthquake load case. But here we have an interesting case because since we have a basement here, ProtaStructure performed a two-stage analysis. And for the basements, you have the basement load case. And we have also some soil effects here. So our user applied a soil load on this shear wall. You can see the pressure here. Say, okay, the shell pressures. Here we have applied HX load case. We have load here, as you see, in analytical model. Let's get rid of this one. So this is the place where you interrogate the analysis model, and you can, of course, always check the modes. Let's see what we have. In fact, this is not a desirable mode because the first mode is torsional here. We don't want the first mode to be a torsional mode. In the most of the seismic codes, this is either prohibited or this is penalized. You cannot, you have to revise your structural system to get a better behavior. So the translational modes are most probably second or third mode. And even that, see, okay, stop this. Okay, let's second mode, animate. Even the translational modes here are coupled because as you see, it's not a pure translational mode. It is translating and rotating. So these are not ideal as well. So we have to be careful about this model behavior, vibrational behavior of the structure and revise the structural system accordingly. And finally, maybe we can see some contours. Maybe the displacement contours in the G-load case. You can always see the results here. All right, let's move on. Let's go back to the other model. We have here vertical earthquake model. Okay, as you see, this is a special structure. In fact, this is somewhat imaginary because it has a large span beam here. And also it has large cantilevers, a very large span slab. And also we have openings, we have waffle slab here, we have, how to say, the stairs, etc. We have inclined columns, sloping columns, slanting columns, sorry, and we have the column sitting on a beam. So these special structures obviously require a vertical earthquake analysis with model response spectrum. So let's directly see the analysis result. Okay, here what we did, let's change the view. First of all, let's see what we have in EZ vibration. You see we have members and slabs vibrating in Z direction because in this case we have activated the Z masses in the system. And also let's stop the animation. And in the vertical mode shape, the first mode is dominated by the slab here. And the second mode is dominated by these two stories. And this third mode, like this. And you see structure has different mode shapes in different mass accumulations. But EZ load case is the combination, model combination of all the modes here. So we have such a combined behavior here. And of course, let's stop. We have diagrams. And these diagrams, let's close the labels here. And these diagrams will be either positive or negative, depends on the mode shape and the combination. That's why we always include the vertical load case, positive or negative, in the combinations. And before finalizing the analysis parts of my presentation, let's get back to the previous model maybe, because what we have important here is the post-analysis checks report, because we collect all the earthquake checks in this post-analysis checks report. So we have the irregularities like soft story, mass irregularity, weak story, torsional flexibility, mass participation checks, wall frame checks, especially for Eurocode. This is important because if you have a dual system, frame and the shear wall interaction system, you have your frames and the shear walls must be sharing the base shear in certain amounts. So this is the table where we check it, and relative drift check, second order requirement checks, etc. This is a very important report that we have here. Okay, let's go to maybe. Okay, this is our simple project. And for the design, first of all, in the design ribbon, we have the concrete design part and the steel design parts in two separate categories. For the columns, we have the batch design capabilities. So you have all the columns listed in your structure. You can do a column design in batch mode. You can select the members from scratch, or you can check the steel, because in ProtaStructure, you can have revisions. For example, you modeled the structure, you designed the reinforcements, then all of a sudden you had to change a member dimension, or you have to add additional components. You don't have to reselect the bars from scratch. You can come here and you can select the check steel options. Check steel options will not touch the existing reinforcements. If you want to select new reinforcements, if the existings are insufficient, you can select the first option. If you don't want to select, even if the existing reinforcement is insufficient, you can select the second option. Or if you want a clean slate, you can reselect all bars. This is the approach in ProtaStructure. If you double click in one of them, you will see the details. There are some important items here. First of all, this is a rectangular column, and we have shear design, let's say links and link patterns here. This is also a global setting, but you can select a double link, triple link, or single link for the columns in order to satisfy the containment. Okay, ProtaStructure will automatically put the links or the tie bars between the longitudinal bars. Okay, you can see the interaction diagrams here, or you can interrogate the member diagrams for different combinations, and you can get a report here. And while you are here, you can also check the strong column weak beam. If a seismic code is active, most of the time, strong column check is part of your design. You can also come here for this column and have a look at the connection that it connects with K210 and K211 beams. And for this connection, the strong column check is satisfied. And also, you can get the joint shear check for this column. This is also satisfied. Of course, for these checks, beams must be designed as well, because strong column and joint shear checks are post-design checks. You have to finish the reinforcement design, then you have to check this strong column and joint shear. And these two checks are also available for all the joints in the structure. These are here for spot check only. Anyway, let's close this. For seismic code, of course, this is not in all the codes, but for Eurocode and Turkish code especially, you have the tension shift, shear wall envelope, and you have the critical check that you have the end zones accordingly. Anyway, so this is how we do the column design, and when we have the beam design, the logic is the same. You have the beam design in batch mode. You can still use the check steel options here. And in addition to the column for the beams, we have a grouping. So you can group the beam axis, not individual beams, but the beam axis. So if they are similar in geometry and section, you can make them group and you can select an atypical bar for these members. Anyway, let's double click. Oh, this is the simplest one, sorry. Let's double click in one of them. In this model, I have a bent up pattern, but it doesn't matter. You can select a standard pattern as well without bent up. This pattern system is also very powerful in ProtaStructure. This is all interactive. You can change the bars here. And as you change the bars, the design will adapt itself accordingly. Anyway, so this is the beam detail interface, but we have a detailed report here. Let's see what we have. In the previous years, we spent a lot of time and resources to introduce the detailed reports, the step-by-step reports. So you can have all the formulas, the calculation steps here. So you not for all of the members. If you, of course, this detailed report for one beam axis here is 62 pages. So you please do not attempt to get the detailed report for all of the members in the structure. It's not for project submission purposes. If you want to spot check the beam, verify the results, you just select the one beam axis and get the detailed reports for that one. And other than that, we have the summary report. This is the one for the project submission. As you see, it is 6 pages. And we have the stroke column checks here again. Anyway, this is pretty much the beam design, RC beam design functionality in ProtaStructure. And maybe we can briefly touch the steel design. Here I have a very simple steel structure, and all I have to do is go to the steel column design here, and all the columns will be listed. And if you double click in one of them, you will see all the checks here.
We're just seeing your Mustafa. We're only okay. Now we can see it. Now I can see it.
Okay. And of course, you have the detailed report for the steel numbers. This is the steel column. And we have other, let's say for the steel truss, we have the dedicated steel truss design. Let's see. Okay, this is a special UI because you see the truss itself with utilization ratios and all the sub-members in the truss. And then you double click in one of them, you can get the details as well. So this is pretty much the steel design. I will not go into the details of it. You can always get the detailed reports or play along with the members to see how they react to different scenarios. Anyway, let's maybe we can briefly talk about the foundations. I don't know how much time I have. Time.
Well, you can have another 15 minutes. Is fine.
Okay, great. Let's talk about maybe foundations. Here, I have a very nice model prepared by one of our colleagues from India. So this is a tower structure, some of the tower structure. And as you see, we have curved beams here and also rib slabs and shear walls as well. But the interesting part here is let's go to the foundation. Here, they modeled raft foundation, but it's not a single raft. It is a partial raft. They just did a combined pile cap or raft under a column with slab member, and then they modeled the piles on that slab. You don't have to use a pile cap. You can do this as well. It's very easy. All you have to do is just model a slab and insert the piles. That's all. Here you see I have a column, two shear walls, and a core wall, and they are sitting on a combined raft here. So you can use the finite element analysis to design this configuration. And also for this pile, select the properties. You have to assign some capacity, and you have to assign uh, pile spring coefficients, like here, because in ProtaStructure we are not doing the pile soil interaction. You have to represent the pile here with a single linear spring coefficient. That's the challenge you have. But once you insert it, you can model this pile foundation as well. Okay, let's another one. And this is again one of the powerful features in ProtaStructure here. You see I have several basements here, and I have an elevator shaft going down the foundation, and I have one foundation level here, another one here, and another one here. Of course, this is an exaggerated model for demonstration purposes, but you can have different slab levels acting as foundation. These are all, by the way, modeled at the foundation level when you look at from the plan. And then when you go to the analysis model, you can see that the entire building is modeled in an integrated manner with the foundation slabs. Okay, and you can do a full soil structure interaction effect, building sitting on elastic foundation here with the shells and the soil springs defined in the model. This is one of the foundation types you can model in ProtaStructure. And another one, let's see. I'm switching between projects. I hope you are not irritated by it. This is a factory building from, again, one of our users. A very interesting building. But this time, let's go to the story, foundation story. We have pile caps. So let's go to properties. You can always design pile caps like this, but in this case, we design the pile caps with a rigid pile cap assumption. Okay, this is the rigid pile cap, and we can design the piles, and we do all the deep beam checks, all the pile cap checks, and give you a report at the end. Let's see what kind of a report we have. Other than that, we have, of course, the raft foundation, as I mentioned. We have the pad footings, file caps, strip footings, all are in the scope of ProtaStructure. Okie dokie, let's go to maybe I can briefly talk about ProtaDetails since I have not much time left. I can be quicker maybe. So after you design the structure, of course you will prepare the detailed drawings. ProtaDetails is the software or products that you can do it. So let's see, the design is complete. I have selected all the bars here. The ProtaDetails is opening at the moment. Okay, what I want to do is I want to generate the details. I want all the details. Okay, with one click, you get all the detailed drawings, floor plans here as well, the column application plans, the quantity takeoff for the columns, column elevations, their section drawings, the column schedule drawings, beam detail drawings, beam rebar table, and beam elevation quantities, all are available. And of course, the staircase, the stairs that we modeled in the view, their detailed drawings is also here. But one important thing here is that, okay, these rebars are in fact intelligent rebars. They are not just lines and text. So when you click on one of the rebar, you will see that it has a certain property here. Let's see, this is number 17. The bar mark is 17. And where is 17 here? We have fee 16, 10, and length is 800 millimeters. Let's see, if I make it maybe, sorry, let me also check. Okay, where is that? I have 590 kilogram. Maybe I can make it 24. Or not this one here, sorry. Because the bars here, ProtaDetails is intelligent because the bar underneath the beam is just a view of the bar here. This is the actual bar, and this is the view, one of the views of the bar. And the section is automatically updated, as you see here. This is dynamic. And let's see number 17 again. What's the bar mark? It's now 36 instead of 17. Where's 17? 17, the number has changed. And let's see the total amount. And the total amount is also changed. Okay, ProtaDetails is not only a detailing tool, it's a CAD tool. In fact, what you can do here, you can insert lines, circles. You can use ProtaDetails as a CAD tool. It's like an AutoCAD LT. It supports the command line. It has layers. It has text styles, dimension styles, all of it. So you can use the ProtaDetails as a standard CAD tool. On top of that CAD tool, we have all the detailed drawings from ProtaStructure with a single click. You don't have to draw them all of them at the same time. You can go, for example, select and draw only a single one, or you can use a sheet command. Sorry. Continue. Say okay, insert. You can use the predefined sheets. You can customize these sheets, by the way. You can always use the move command to place your members, place your drawings. For example, it has this beam elevation isn't fitting to the sheet here. So in the detail library, we have a crop beam elevation option. You can crop it and take it to the other side of the sheet. And also in this sheet, you can always let's come here, and maybe put draw here the plan. And in this plan, maybe I have detail library, the building section. This is a new functionality here. Let's switch to orthogonal. Okay, sorry. And you can get the building section in ProtaStructure 2026. Okay, let's move this as well. You can move this. And maybe here I have column elevation. In story one, I have two here, and maybe S4, not like this, but through stories. For all stories I have S2, it's not fitting. Of course, what you can do, you can always stretch the, let's move this. As you see, I'm using it as a CAD tool. You can be very comfortable with it. You don't have to be nervous about it. It's just a CAD tool. Stretch. Okay, and move it again here. Something like this, and true stories. Again, like this. Okay, maybe I can move it here. Of course, this is not maybe quite realistic position, but you get the idea. You can just put anything in the sheet in ProtaDetails. And what I will do at the end, okay, I will do one more stretch here. Okay, and what I will do in the detail library, I will put a shear wall elevation. This is nothing but a formwork drawing. And in the reinforcement rebar, I will insert a rebar. I mean, let's select the type. What kind of a type? Let's say we have this one. I have reinforcements with 4 points. And from here to here, here to here. Okay, one reinforcement here. And let's another one. Rebar, 4 points. Let's select the type. Again, this is the type. You can, by the way, you can always select the diameter, the multiplier, and the scale of the scale factor of the rebar. The scale factor depends on the scale factor of your drawing. For example, if you are working on a 150 scale, and if you want to draw a 20 scale drawing on this number, you have to select the scale factor as 2.5. Anyway, just for the demonstration, maybe I can put something like this. And now I have two reinforcements. I have a composite sheet here. All I want to do is quantity table and select all of them and put the bars here. So you can just quantify any drawing, any intelligent drawing you have. You can even convert, let's say I have a line object here, something like this. A rebar like this, okay? What I want to do is rebar, convert the rebar, and this one. I converted this into a rebar. Sorry, since I drew this line, I could use the polyline. It's better. Let's get rid of the orthogonal. Let's say I have this rebar here. So reinforcement, convert the rebar. So start segments. You can always select the anchorage for the start and the end segments. And you can set the scale factor, let's say 2.5. And rebar usage can be a general rebar. Quantity, let's say 4. Diameter will be 12. Spacing will be 25. And I will just click and convert. So what this feature is handy if you have, let's say, an unintelligent DXF drawing. Let's say you received a formwork plan from one of your colleagues, and all the rebars are drawn with lines or polylines. What you can do, you can convert all the lines to the rebars here, as you see, and you can quantify it immediately to do a value engineering maybe, or to do a quantification. And what I want to do, I want to do a quantity table again, and I want to select all of them. And it will say that the bars are already assigned some bar marks. And I say yes. I put the new one here. It deletes the previous one and puts the new one. Now I have this weird shape rebar as well here. So this is the drafting capability of ProtaDetails in a nutshell. And the other third powerful capability is the design library. So on top of this, we have cantilever retaining wall, for example. It's capable of designing a retaining wall. You can define the backfill, front fill parameters. You can insert some parapet shelves, and you can design the reinforcements in the stem and in the base plates. You can do all the stability checks or total failure checks here, and it will create you reports, detailed reports. Let's see. And a drawing. So this is the drawing. And similarly, you can have a pile design functionality. If you have a pile that you want to do a pile design for pile soil interaction design, all you have to do is calculate working load, calculate lateral analysis. You can insert the soil profile. We have some default values. We have some design parameters and SPT values. Okay, and we have the working loads diagrams here. So how the capacity of the pile changes with respect to depth, and also the design parameters here, and you can design the pile section. And all of a sudden you have a model diagram and the results for the section: shear, deflection, soil pressure, traction diagram, pile section, PY curve, etc. And we have other design capabilities like corbels, head footing, pool macro, hull cap. Again, you can perform an independent hull cap design here. And also if you have a steel facade scaffold, you can design the scaffolds as well. This is a very specialized tool in ProtaStructure. All you have to do is just start analysis. It will analyze it with finite elements. You can export the results to SAP 2000, or you can just create the details. So ProtaDetails is powerful so that it includes such powerful engineering library inside it, and you can create the detailed drawings and the drafting independently in ProtaDetails. That's very handy. Okay, let's close it. And let me finish by briefly talking about ProtaSteel. So let me show you another simple model that I made. Okay, after you finish your steel design in ProtaStructure, you can just open ProtaSteel for designing the connections and creating the detailed drawings. When we send the model to ProtaSteel, not only the geometry, but also the internal forces. Let's double click. You see the internal forces are also in the members. So ProtaSteel is a software, powerful software, very similar to Tekla, because it has all the conventions that Tekla has in it. It's tailored for steel drafters and engineers. But on top of Tekla, ProtaSteel is also able to do connection design. As you see, we have the internal forces here, and using these internal forces for each combination, let's see the table view. So we have the results for each combination. So using these combination results, you can do the connection design inside ProtaSteel. And we have also a new functionality. You can, if you have a connection, you can send it to ID Aesthetica, and you can also do a finite element component design in ID Aesthetica. But you don't need ID Aesthetica. Inside ProtaSteel, you can do the connection design, as I said. And this is pretty much a 3D software. It's very similar to Tekla. You have all the commands like work plane, coordinate systems, etc. You can play with the members. You can adjust the member positions. You can do all sort of modifications in your structural model. But when you send the model from ProtaStructure, the entire model is pretty much ready for production. For example, you see the girts and the trusses and the purlins are all in exact positions. So let's say, for example, here, if I have a connection, beam to column connection, say I have a stiffened end plate, here you can insert it quickly. So maybe if you have a bracing connection here, sorry, so you can insert a gusset plate, or you can insert a purling connection here, or a girt connection here. This is pretty straightforward. And also, let's see where am I? And selecting from this macro, this is of course a macro. You can select one component and hit the macro properties. You can see the macro properties here. You can customize the macro, fine tune the parameters, and make it adjust to your standards here. What I want to show you is the connection design reports. Okay, as I said, the connections in ProtaSteel can be designed. So this is the typical connection report in ProtaSteel. So you have the step-by-step formulas and the design checks listed here. This is valid for all of the connections that you define in ProtaSteel. And also, we have a very powerful functionality called IntelliConnect. So you can create the purling connections, maybe with the angle type, next, and run. and it will automatically create all the purling connections at once. IntelliConnect is quite smart. It will assess the condition, joint condition, and will decide on the proper connection, and it will also recognize the existing connections as well. So maybe here, let's put another different end plates. Purling, there's a purling connection here. Okay, maybe we can use again the IntelliConnect to do the truss connections for me. That's 10 millimeter gusset plate. Okay, so you see all the trusses are connected with the gusset plate connection. Anyway, let's select the assembly and show only selected. You will see the assembly that will be created on the site. Okay. And before going to drawing, what you have to do, you have to perform numbering. Numbering completed. Because in order to create the assembly drawings, you have to have some sort of numbering. And for this one, let's create an assembly drawing. Let's see, this is the assembly drawing for the column that we created. Let's close it. See the drawings again. What we have the views. So let me maybe create a 3D view. Drawing, general arrangement 1. And from the views, because in ProtaSteel, everything is a view. Every view is a different representation of the 3D model, and you can insert these views, and you can annotate this one again. Maybe I will have profile name, some below here. And I will annotate them. You can annotate any profile, any view inside the general arrangement drawing. In ProtaSteel, general arrangement drawings are semi-automated. You have to create your general arrangement drawings yourself, but you have all the tools. You create the drawing yourself. So I won't be talking about ProtaSteel too much because there are a lot of details here. You can do the user-defined connections. You can use commands like bolts, plates, welds. You can create your custom connection, and you can communicate it to the IDEA Statica, or you can use it in other projects as well. It's a very detailed software. You can do all the steel drafting here, but in this limited time, unfortunately, I will not be touching all the functionalities. This is a very, very brief overview that I can tell you at the moment. This is all I have to talk about today. I hope you enjoyed it. I tried not to be monotonic. I tried to show you different scenarios, different models, different. I tried to give you different information on different capabilities. I hope I managed it. I hope you liked what you saw today.
Yes, you did. You
Thank you.
definitely did.
Yeah,
Great job.
thank you very much for your time. I'm handing over to Jaime for the introductions again.
Great job. Great job, Engineer Mustafa. It was an excellent presentation. So now I'm going to hand it off to Engineer Idu. As I said, he's our Nigerian partner. He's going to tell you just a couple of things of the local market, of how we are, how this product is properly applied out there. So just let's have Engineer Idu connect with us a little bit and explain. You have a few minutes for us. Are you ready?
Yes, let me. Okay, thank you. And I'll try to finish within 5 minutes, even though I had planned, but uh, because of time. So I'm Engineer Drofiku, and the good thing about my own perspective is the fact that I am very active in the industry. In Nigeria, I use a software. So most times when I talk about it, I don't talk from the point of a salesperson, but more from a point of somebody whose efficiencies as far as design is concerned, not just design, even at site. I use this software to do a whole lot of supervision because from time to time, the issue of changes that come, we have a project ongoing and even up to the second floor, the owner is still making changes. And all we have to do is to check if those changes can be accommodated. And this is what ProtaStructure has helped me. Sometimes at the site, I'll ask them to just hold on. And then I sit, I check. So I'm not going to bother you so much because of time now. But whether you have issues with soil, which has to do with a lot of geographical issues, like if you go to Southwest, you encounter different kind of soil stratas, conditions reclaimed on marginal land, differential settlements. In those cases, piles and rafts are no longer optional. They become basic. When you go to South-South, aggressive groundwater, hydrostatic uplift, basement walls, and act as retaining structures, even for water. So when you go to Southeast, and Southeast, I can tell you, this project here, this was the stage I stopped before I left uh, Enugu State in 2023. And I can tell you, this project was designed by me and supervised. And I have a whole lot to say about the type of soil and how well ProtaStructure helps me. So most you are faced with gully, erosion, slope, instability, retaining walls and step foundations become the order of the day. When you go to North Central, like Abuja, you don't have much issue with the soil. But the issue here now is the efficiency, how you should not over design, where you don't need to use pile. You don't have to use pi. Uh, this is one of the features that of the many features that ProtaStructure will help you. So when you go to Northwest, you have all their own peculiar challenges. Like I said, I don't want to go much into it. Now, wherever you are, be it in Abuja, be it in Lagos, Port Harcourt, Nairobi, Accra, any other part of the African nations, you the challenges are almost consistent. You are faced with complex foundation, basement and retaining issues, structural interactions, frequent revisions to architectural drawings. I know that Mustafa has touched so many of these features. Then the workflows are just there. When the architectural drawings are reviewed, are you going to start all over? No. With ProtaStructure, you don't have to do that. Will you remodel, foundation basement, repeating analysis, detailing, lots of time and consistency? This should be able to make you make an informed decisions. What does an engineer need, regardless of where you are? What a tool must do, and whatever tool you are settling with, if it doesn't do it as an engineer, then you can't make it a choice. I'm happy you've gone through with Mustafa and most of those features which within the constraint of time he couldn't go through all. So now, but what an engineer always needs is one consistent structural model. You don't have to have a segmented model. You use Excel to do your load analysis. You pick another software to do another thing you pick. In the course of time, errors begin to happen. And that's why most times on site, you see poor coordination between the architect and the structural engineer. Wherever you are, elements have to work together. You don't have to always use rule of the thumb when you can confirm using ProtaStructure. Then you don't have to restart all over, even when there are changes. Then you must have a clear documentation for authorities, for everybody that needs to look at it, even you, for proof checking, to be sure that whatever you have done is safe. Then, how ProtaStructure fits this reality? Good enough, you have gone through most of them with Mustafa. ProtaStructure has integrated structural model. Just from one point, you do all your modeling. You can handle all your native elements as they are. If your beam is 225 by 450, you handle it. No more assumption. There's nothing like assuming what is not. Then there's a continuous workflow from modeling to drawings. Mustafa has already demonstrated that. You do your modeling, run your analysis, and then do your designs, your reinforcement designs, your steel designs, and you proceed to drawings and documentations. Then Nigeria and beyond want to for recurring engineering problems. Same problem patterns across Africa, same workflow pressures, same expectation that is demanded of us. So all you need to do is just to turn to ProtaStructure, and with this I'll use the opportunity to let you know that As many of you who need a demonstration, there's also a provision for free demonstration for your team. So if you want to know further some of the capabilities of the tools, and as many that are buying the software, if you are in Nigeria, you can contact Trafford. We're on LinkedIn, or you send your email. Even when you send your email to uh, sales at protasoftware.com, they will see direct you to us. So because of time, this is where I want to stop. So thank you as I hand over to Yami.
Thank you so much. It was a great presentation. I know that you were very limited in time, and we're going to be closing up in the next couple of minutes. All right. As I told everybody, remember to download your trials, okay, if you want. And just one thing that you will have to keep in mind is which Prota edition is going to be right for you. Okay. We offer three types of editions, which is standard, professional, and enterprise. Here you see a small summary of some of the main differences. Standard is limited when it comes to stories and actual columns and walls per story. After that, there's really not much differences, except obviously you can export anything having to do with steel. A professional and enterprise have no limitations when it comes to flooring. And pretty much the big difference is that enterprise includes everything having to do with steel detailing. Just reach out to us at Global Sales for more